All right, this one was fun. So the purpose is to add up all of these equations so that all that's left standing are these reactants, these products. And what I mean by left standing is if several of these equations have one molecule in the reactants and that same molecule in the products, they will cross off, as you'll see. All right, so this is how I start these. I figure out what makes it to the end. Methane, for instance. This is the only equation that includes methane. I need two of them. Got a little bit of a problem. Not really. I'm allowed to double the coefficients as long as I double the enthalpy of reaction as well. So you can see I've done that. Next, C₂H₄. I've only got one source of it. That's the green, except it's on the wrong side, but that's fine. I can flip the reaction and flip the sign on the reaction enthalpy, as you can see right here. But now I have a bit of an issue. This H2, I've only got one on the correct side. Not to mention, I have a bunch of intermediates that need to go. I need H2O, CO2, water. Those don't make the final equation. I can start to remedy that with this blue equation. I can get my second hydrogen by flipping it, of course, getting it on the product side and changing the sign with the enthalpy. And now this final piece is what all that it does. The only purpose of this purple is to eliminate what I no longer need, which at this point was oxygens, CO2s, waters. So watch this. Out. I've got a water here and a water here on the reactant sides that are crossed out by this 4 water bunch over here. I've got half O2, 3.5 O2 on the product side that then eliminates the 4 oxygen on the reactant side. Oh, and I almost forgot, last but not least, this guy is on the reactants and on the products. Done. So you'll see all that's left standing: 2 methanes, 2 H2s, 1 C₂H₄. You will then add up all these enthalpies and you have your overall.